Very good afternoon to all eminent dignitaries and the research scholars present here today. I would like to thank organizing committee of CST for providing me this platform to present my work. Before starting of my presentation, I would like to introduce myself. I myself, Vijayalakshmi, presenting my work on performance analysis of supervised algorithms on different applications. Under the guidance of Dr. Jayapal and Dr. Supreeti Kamilya. Sir, my slides are visible?
Yeah.
Excuse me?
Yeah. Yeah, Vijayalakshmi.
Thank you. So, yes, analysis of supervised learning algorithms on different applications. Under the guidance of Dr. Jayapal and Dr. Supreeti Kamilya from Birla Institute of Technology, Mesra, Ranchi. Outlines of this presentation is motivation, objective, introduction to machine learning, followed by supervised learning algorithms, classification algorithm, performance analysis using supervised algorithms, SVM statistical analysis on 3 applications, followed by conclusion and references. Motivation of my work is as follows. In the modern era of computation, machine learning is applied on broad area of research fields because prediction became an easy task if we use the machine learning algorithms. Reviewing machine learning works in different fields will help in effectively predicting the results in the future. Objectives of my work is to focus on the performance analysis measure of various supervised machine learning algorithms in terms of accuracy, precision, sensitivity, and specificity is given for the above mentioned applications. The above mentioned applications are stock market analysis, undergraduate admission data, and breast lesion detection, and also comparative analysis of SVM classifier is shown in the paper on these 3 different applications. In the introduction to machine learning is used to find patterns and associations within highly complex data sets. Machine learning techniques are making solutions for real-world applications, and also machine learning requirements are increasing day by day due to ever-growing data sets. Here, machine learning methods are given in three different methods are there under machine learning. One is supervised, second one is unsupervised, and third one is reinforcement learning. This is the graphical representation of a combination of all these 3 methods of machine. Supervised, coming to the supervised learning algorithm, the aim of the supervised learning algorithm is to find a mapping function to map the input variable with the output variable 1. It provides input-output relationship, that is y equal to f of x, where x is the set of independent features and y is the target function. It uses the labeled data sets to train the algorithm to recognize the data and properly predict the outcomes. In supervised learning algorithm, the training data provided to the machines work as a supervisor that teaches the machine to predict the output correctly. It applies the same concept as a student learns in the supervision of the teacher. And the learning process of providing input data as well as correct output data to the machine learning model. Supervised learning is a hello, sir.
Yeah, you are audible. Please continue.
Okay, sir. Thank you. In this example, we used in the supervisor, this is the supervisor learning algorithm. So here we use the label data. This label data consists of two different set of classes. One is set of apples and the other one is the set of strawberries. Here using this labeled data, algorithm is trained and predict the output as an apple or a strawberry. Predict the outcome. That means if your raw data is given, an image can be predicted either an apple or an strawberry. Next method is unsupervised learning. Unsupervised learning works on unlabeled and uncategorized data. Unsupervised learning helps to find the valuable insights from the data. Because in the real world, we don't always have input data with the corresponding output. So to solve such cases, we need unsupervised learning. In this example of unsupervised learning, we have raw input data. This data consists of different objects. And after applying this algorithm is trained based on the similar characteristics or dimensions of the data and predict the output into three different classes. So one is set of apples, and the one is melon, and the other one is carrot. Next method is reinforcement learning. Reinforcement learning differs from supervised learning in a way that in supervised learning, the training data has the answer with it. So the model is trained with the correct answer itself. Whereas in reinforcement algorithm, there is no answer, but the reinforcement agent decides what to do to perform the given task. This is the example of reinforcement learning. And then classification techniques. In classification, the labeled data is discrete, but in the regression, it is continuous form. A classifier is designed by reducing the existing clusters and the training data set. The following classification algorithms are discussed in our presentation. So one is linear discriminant, logistic regression, naive Bayes, support vector machine, KNN, random forest methods. These are the classification algorithms. The first one is we used, that means we presented logistic regression. This algorithm is used to determine the probability of an binary event. When the dependent variable comes in the binary form, we use this logistic regression. Second one is KNN. Because of the ease of interpretation and the short calculation time, this method is well known for its simplicity. In this method, KNN saves available cases and categorizes new instances based on the homogeneity similar to the distance function. Third is decision tree algorithm. It looks like a tree structure that categorizes instances depending upon their characteristics. Each internal node represents a test case, branches shows the result of the test, and leaf node shows the class labels. Next, coming to the naive Bayes algorithm, it is one of the statistical classification approach used in the supervised learning algorithms. It provides a posterior probability of belonging to a class given input features. Here, this formula is used in the naive Bayes. Here, in this formula, P of A by B equal to P of B by A multiplied with P of A, probability of A, divided with the probability of B, where A and B are the two independent events. And probability of A and probability of B are the probabilities of A and B. The conditional probability of P of A by B is the probability of occurrence of an A given an event B. P of B by A denotes the chance of observing an event if the event A is true. The next algo is support vector machine. SVM is an ML algorithm that solves problems of classification and regression. The SVM model is supported by the margin calculation idea. This method can be applied to both linear and non-linear data. Random forest is a special kind of ensemble learning algorithm used in the classification and regression problems. A random forest is the forest trees, each based on the different bootstrap example from the training data. When a tree is fitted, some predictor variables are censored at each node. Multi-layer perceptron. This network contains 3 layers. Each layer, except the input layer, it operates like a neuron and uses a non-linear activation function. Backpropagation is a supervised learning approach which is used to train the MLP network. Next, performance analysis using supervised learning algorithm. Here we analyze the performance by the following supervised learning algorithms, which I have already mentioned in the previous slide, what all the algorithms that we have considered. One is linear discriminant, logistic regression, naive Bayes, support vector machine, KNN, and random forest. Performance analysis using the supervised algorithms is first done on the established works. Among the various supervised algorithms, SVM is shown to be a good classifier that can be commonly applied to all the applications used in this study. A comparative study of SVM statistics on the said application is presented in this paper. We considered 3 pre-established works for stock data mining, undergraduate admission data, and breast lesion detection. In the first application, stock data mining, 12 years of renowned bank stock data is used in the study. The performance of 4 different supervised learning approaches, that is support vector machine, random forest, naive Bayes, and artificial neural network are compared for the particular study. The correctly and incorrectly classified instances are used to calculate the performance of predictive classification models. Various statistical measures such as accuracy, precision, sensitivity, and specificity of different supervised classifiers are analyzed in this data set. This work, second application is undergraduate application. In this undergraduate applications, the work focuses on how machine learning techniques can assist admission counselors in concentrating their efforts on applicants who are more seemingly to join. This admission process is carried out in 3 stages: stage 0, stage 1, and stage 2. In the stage 0, the applicants fill up their application forms. In stage 1, admission counselors evaluate and select some of the applicants. The applicants accepts the request of counselors in the stage 2. SL techniques are employed to classify the stages 1 and stage 2. In the undergraduate admission application, the predictive model consists of three phases. One is data processing, second is classification, and third is feature selection. In data processing, raw data provided by the admission cell is converted into a numerical form and accepted by classifier. The classifiers are trained to make valuable predictions about future applicants in the classification phase. In the third phase, classifiers are used to determine the features in the application that are dominant in the stage 1 and stage 2 predictions. Classifiers are used to predict stages 1 and stage 2 relevant to the admission scheme. The first stage indicates whether or not an applicant is accepted. The second stage indicates whether or not approved applicant attends the university. In the training process, 5 classifiers such as multilayer perceptron, linear SVM, polynomial SVM, and quadratic SVM are trained. Different statistics have been measured to find out the classifier with the highest performance rate. The performance rate is considered in the validation set, and the same classifier is used in testing the current data. Third application is breast lesions detection. An automatic computer-aided detection and diagnosis system of breast lesions is presented in this study. The developed model is dependent on supervised machine learning algorithms. These techniques are used to classify whether the breast lesion is benign or malignant. 4 different machine learning algorithms are examined for classification. One is support vector machine, and the one is k nearest neighbor, third is random forest, and fourth one is naive Bayes classifier. The valuation metrics are used to demonstrate the study success are accuracy, sensitivity, specificity, and precision. In this performance analysis, the performance analysis of these 3 classifiers in the referred applications are given in the tabular form. The first application in the stock data mining, out of all the classifiers, logistic regression is showing highest accuracy. In the undergraduate admission data, this MLP is showing the highest accurate rate. In the breast lesion detection, random forest is showing the highest performance rate in terms of accuracy. And the analysis of this tabular form and another graphic representation have given in the next slide. So this is the SVM statistics. So comparative analysis of the performance measure of SVM algorithm for the 3 applications are represented in the graphical form. This is the graphical structure of SVM statistics on the 3 different applications. In terms of accuracy, stock data mining is showing the highest accuracy, and undergraduate admission showing the moderate, and breast lesion detection is little lesser than other. In terms of the precision measure, stock data mining is showing the highest precision rate. Undergraduate admission data is moderate, and comparative with other 2, breast lesion detection precision rate is less. In terms of sensitivity measure, stock data mining is showing less sensitivity rate. Undergraduate admission data is moderate, and breast lesion detection application data is showing the highest rate. In terms of the specificity measure, undergraduate admission data is performing the highest rate of sensitivity specificity, and the least is stock data mining. And undergraduate admission, in the terms of specificity measure, undergraduate admission data is highest, and breast lesion detection is moderate, and the stock data mining is very less. SVM statistical analysis on these three applications. From the table, we can make one comparative analysis on these three mentioned applications using the SVM classifier. The SVM classifier shows better accuracy in the stock data mining application compared to the other applications. In terms of other statistics such as precision, sensitivity, and specificity of SVM analysis, from the above graph, we found that there is not much variation in the precision value of stock data mining application and undergraduate data application. However, in the comparison of these two applications, moderate interpretation of precision is found in breast lesion detection. Hence, we can say that precision value is better in the stock data mining applications on the overall analysis. Sensitivity is higher in the breast lesion detection, lesser in stock data mining, and moderately high in undergraduate admission data. Coming to the specificity measure, it is less in the stock data mining applications than in the other two, but it is quite good in the breast lesion detection. Finally, we conclude that performance analysis of different supervised learning algorithms on three existing applications such as stock data mining, undergraduate admission data, and breast lesion detection. Under the breast lesion detection have been discussed in the book. It has been observed that support vector machine is commonly used algorithm among all the supervised algorithm that ensures good results in terms of different metrics. In this work, we have compared SVM for all the three applications. In the future, as a future scope of study, more applications can be used to analyze best supervised algorithms for classification. These are the references which I have taken for my work. Thank you.